steam pressure curve of saturated steam Marcet boiler. Okay, so before we go further on this experiment, let me read first the objective. The first one is to study and understand the relationship between the pressure and temperature of saturated steam in equilibrium, while the second objective here is to study and demonstrate of the vapor pressure curve. So basically, if you read the first objective, we will concentrate on the two basic parameters in thermodynamics, which is pressure P and also temperature T. And then the condition of the steam, here we focus on the saturated steam condition only, right? So basically, before we go the details or theory on this saturated steam condition, that I bring you into a simple example at home or in your kitchen when you want to boil your water or you want to boiling your water, okay, using your kettle. So what you will expect is that everyone know that when you want to boil the water at home, and when you learn during your school, the boiling point of water should be 100 degrees Celsius, right? Alright. So this state that you will say that this water already cooked, alright. But typically the scientific word we call as the water is already boiled lah. So the water already boiled. Alright. So this will happen only if at the standard atmospheric temperature or standard atmospheric condition, which is at 1 atm. Okay, so this is also equivalent to 101.3 to 5 kilopascal. But when you want to boil the water at the different place, specifically on the higher altitude on the lower altitude of the earth. So basically, if you go at the top of the mountain, let's say on the Everest. Okay, here, this is the Everest mountain. So the height for this Everest mountain basically higher than 8,000 meter. So if you go at the top level of the earth here, means that your thickness of the air there will be lower, and this will bring the density of the air will be lower also. So because the pressure is a function of the density, it means that if you have the lower density, you also will experience the lower pressure here. Let's say it's around 50 kPa. So what will happen if we boil the water at this value of pressure? Okay, so what will happen is that, and also if you go deep into the ocean, you also will have different value of pressure, because the density of air there is also different. But basically that is the pressure is due to the buoyancy force of the water, right? But the pressure will be different also. So the water, if you want to boil the water, also will be disturbed. It will not be exactly at 100 degrees Celsius. This is due to the condition of the water itself. Alright. So if you have the higher pressure, it means that the condition of the water, or the collision, or collision of the water or molecule of the water is high, right? So in order to break the bond is also different. Okay, so you need to have extra energy to break the water, or to what you want to boil the water or change the state from one state to another state, right? So same like if you have the lower density of the water, it means that the movement or collision or the energy of the water itself, right, will be lower, so that you will have a lower energy to break the bond from one point, from one state to another state. So basically, if you learn in your thermodynamic class, we have 5 different states of water, or specifically we say that steam. Okay, the first one is a compressed liquid. The second one is a saturated liquid. And then we will go into the next level, which is a saturated liquid vapor mixture, or I will just write here as mixture. Next one is a saturated vapor. And the last one is superheated vapor. Okay, but we will not go details into each of these phase or state. Okay, so our interest is to get the corresponding temperature during the saturated condition, which is at saturated liquid or mixture or saturated vapor, because these three phase or state will experience the same saturated temperature. So why there is no change of the temperature? Because the energy that we supply during the heating process is used to break the bond or change the phase from one form to another form. Okay, so in this case, the temperature will not be changed. Okay, so it's not like as a compressed liquid into the saturated liquid, because during this state your temperature will be different first. Okay, and then also from saturated vapor into superheated vapor, they will also have a increment of temperature. So the energy during that state is used to increase the temperature. So there's no change of phase during the boiling process. It's still in the liquid until it reaches the saturated liquid condition. During the heating process from saturated vapor into superheated vapor, both still a vapor, and there will change of temperature, no change of vapor. Okay, so here I will illustrate more of it in this diagram, which is compressed liquid, saturated liquid at state number 2, and then from at state from 2 to 4, or specifically at state number 3, which is lies between state 2 and so state 4 here is a saturated mixture. And then at state number 4 is a saturated vapor, and then it will reach the superheated vapor if you boil higher than the saturated temperature. So our interest is our saturated temperature here from 2, 3 and also 4. Okay, so let's say, as I mentioned just now, if you boil the water at home, you may be familiar with 100 degrees Celsius, but if we change into the lower value of pressure here, what will happen is that, okay, so the graph here will be offset on the lower value also. Okay, so this is due to the energy to break the bond also different. Okay, so most likely the temperature will be lower because you will experience the lower pressure here. So let's say this is 0.5 atm, or I said that 50 kPa first. So this is 50 kPa. So the corresponding temperature or saturated point temperature will be lower. But if you go deep into the ocean, you most likely will have a higher value of pressure. So let's say this is equivalent to 200 kPa. So your corresponding saturated temperature will be higher. Theoretically, we can get this value of temperature using the steam table. So I will bring you into the steam table first. Okay, here. So here is a steam table you can get from the Chingyal's book. So here you need to focus on the table A4 and also A5 because this is a saturated condition of the water. Right? So let's say I want to focus on the 1 atm, which is equivalent to 101.325 kPa. So you need to look at the first column here, which is corresponding to the pressure. So you go here 101.325 kPa, and the corresponding temperature here is 99.97 degrees Celsius at the second column. So this is the saturated steam temperature. Okay, so theoretically you can get this value, which is this value basically is or this table is developed from the correlation equation. But if you want to get the real value, you need to run the experiment and get the corresponding or exact value, right? So you will make some comparison between this theoretical saturated temperature and also the experiment saturated temperature. Okay, and then you will change into another value of temperature and also another value of pressure. So let's say I do at 50 kPa the experiments, and then the corresponding or theoretical saturated temperature is 81.32 degrees Celsius, which is also claimed by me just now. You will have lower boiling or saturated temperature if you go lower pressure, and if you go higher pressure, so basically you will have higher temperature also. Okay, so what you need to do in these experiments, okay, you will do the experiments using the Marcet boiler apparatus. This Marcet boiler apparatus is very useful in order to get the saturated steam at different value of pressure. So you will change the value of pressure, and then you need to record the corresponding saturated temperature experimentally. Okay, so that is your task, and this is very easy. This you have 18 items that you need to look at the label here. So already been labeled, and the procedure you can look at the video step by step. Okay, so I will not penetrate or focus on this procedure, but the only important things that you need to be careful with this apparatus, because this apparatus is deal with high pressure and also high temperature. Okay, so that is the main thing, or the safety things that you need to remember in your experiments. Alright, so we focus now on the result and also analysis here. So in order to do the result analysis, first you need to record and data obtained on the result sheet table 2. So now you look at the table 2, you have 4 columns here. The first one is your gauge pressure, second one is your absolute pressure, third one is your temperature, then the fourth one is the also temperature which you get from the property table. So I said just now is your steam table. Right, so basically you have a pressure from, you need to vary it from 1 bar or equivalent to 100 kPa, and then you need to change it until 10 bar, which is equivalent to 1000 kPa, because 1 bar equal to 100 kPa. But if you want to read from the steam table or property tables, you need to look at the absolute pressure. So you need to change from gauge pressure value from the apparatus, and then you need to do some conversion from gauge pressure into the absolute pressure. So you need to plus with 1 atm or 101.325 kPa, you will get this value. So it's already been calculated for you, so you just need to check it whether it is true or not. Alright, so the highest one here is 1101.325 kPa. So I will take one value here. So let's say I want to get the saturated temperature for 201.325 kPa. So basically, if you run the experiments, you will have the temperature here, let's say 101 degrees Celsius. Okay, sorry, this one not logic lah for if you get 201. Okay, let's say this one is 201, basically 120 degrees Celsius. So what is the value from the property table? So we need to check back the value from the steam table or property tables for 201.325 kPa. Alright, so here if you look here, there on the first column 200 kPa and also 225 kPa. So our value that we want to get is 201.325 kPa, but we do not have this in your steam table. So what you need to do is that you need to do the interpolation method. Okay, the interpolation method is the tools to estimate the value between two value in the correlation table or correlation equation. Okay, so I want to expect what is the value of the temperature at 201.325 kPa. So I need to do two column here for your pressure and also temperature. So I take the first or lower value here, 200 kPa. This one is degrees Celsius. So our interest value is 201.325 kPa. And then 225 kPa is your upper value, and then you need to get the corresponding value for each of these pressure. Okay, so for 200 is 120.21 degrees Celsius, and then for 225 is 123.97 degrees Celsius. So we need to get the x, which is lies between the upper value and also lower value. So this is the interpolation method that you need to do to get the corresponding temperature for 201.325 kPa. Okay, so you need to write it like this. Okay, x minus 120.21, 123.97 minus 120.21. Okay, this is the right hand side of this table, and then you do the same corresponding sequence. Okay, 201.325 on the left side of this table, and 225 minus 200, and then you calculate it. You will get x is equal to 120.41, which is between the value of 120.21 and also 123.97 degrees Celsius. So this is your corresponding saturated temperature if you boil the water at 1 bar. Okay, so this is the value theoretically. So 120.41, and then you need to fill up in your table 120.41. So they are a little bit different, or little bit change from the theoretical and also experimental value. So you need to do for the several points here. Okay, but in your experiments or in your answer, you just need to do a sample of the interpolation. The rest of it is you just extract from the Excel, or if you very hardworking person, also you can do the step or show it one by one. Alright, so that is a very simple method. And then you look at the second result analysis here. It wants you to find the temperature of the steam from the thermodynamic property tables. So this one I have shown you. Okay, and plot the curve at the same graph. Okay, so what curve that you need to do? Plot the graph of the steam absolute pressure P versus steam temperature by using the measurement taken in the experiment and also from the tables, which is from the theoretical. So the value that you get from the experiment here on the third column here, right, and also the fourth column here is your theoretical. Okay, you need to plot it using your Excel in one graph. Okay, make sure in one graph, right? So pressure and also pressure versus temperature. Okay, so this is P kPa, this is temperature degrees Celsius. Most likely you will have two curve here. Alright, one will represent your theoretical value, another one is your experimental value. So basically theoretical value, you will get a very nice curve. Okay, but in your experimental value, so basically maybe you will get scattered data, and you need to fit it using some fitting curve, or this one is a linear curve lah, right? So this is a linear graph, right? It should be a linear graph until and then you need to get the variation of your temperature between the theoretical and also experimental, and then you need to explain it. Okay, so that is the experiment of this lab. Okay, so if you see on the discussion also, it already mentioned about what you need to do. Okay, so you need to do all of these things on the discussion. Okay, And also this is about the result and why. This is why the result like that. Okay, why the theoretical is higher than experiment, or maybe the experiment is higher than the theoretical value. And then the last one is to compare it, which is to give the reason, based on the graph that you have plotted. Okay, so the rest of it you need to read it and also answer it, okay, on the next item or next subtopic. Okay, so I think that is about these experiments, and basically you need to relate it with the objective, which is to study and demonstrate the related between the pressure and also temperature. So now we know that the temperature that we look into have the experiment or also theoretical value, and to study and demonstrate of the vapor pressure curve, which is on this part lah. Right, so basically if you look on this vapor pressure curve, so if we plot it at different value during your experiments, most likely you will have this kind of shape. So if you plot it or get all of the saturated point on the liquid and also saturated point on the vapor, so you will have this curve. Okay, so this we call as the vapor dome. Okay, so all of these things we call as vapor pressure curve or TV diagram. Okay, so hopefully you understand these experiments and enjoy it. Alright, so but make sure during your experiments you need to be careful with the higher temperature and also higher pressure. Alright, take the safety condition and make sure you wear the right equipment or right safety shoes. Okay, otherwise we don't want you to experience an accident or bad injuries. Okay, so be careful, and hopefully you can do the better experiments after that. Okay, see you again on the next experiment. Assalamualaikum. Thank you very much.